So hello everyone. So here we're at the another exciting release for HyperStudy. Thank you for your interest in upcoming features and enhancements. Today's agenda will cover all the improvements falling under these categories: connections and integrations, methods and tools, post-processing and visualizations. Here we go. So the first category is connections and integrations. In this area, we have three distinctive different enhancements or improvements. The first one is the parameterization of additional resource files. So we came across a quite number of scenarios in which the explorers want to parameterize not only the main input files, but additional files on top. The conventional way was to create another parameterized file model and then link the files to the main process. So with this new implementation, the extra files added through model resources can now be parameterized. I'll dive into a demo and show the new feature. Bear with me. Okay. So give you a bit of a background. This is a beam model for OptiStruct, and this FEM file is referencing an include file called material, which has all the material information in the respective file, which is sitting in the study directory, in the same directory with the main resource file. So if you look at it, so this one has all the material information. What I do is I turn this material file into a template file, TPL file. And what I've done is to parameterize the Poisson ratio, for example. And after that, go to model resources. When you add a input file, you can pick the template file, material template, and make sure you put it the right template option. And then after here, you can just put the extension, whatever is needed for the process to work. So in OptiStruct case, there's no extension, so we just call it material. And as soon as I import variables, I will have two design variables. Thickness is coming from the main resource file, which is the beam FEM. The Poisson is coming from the include file. Not only that, you don't have to maybe templatize the include files. You can also do it on the fly here when you right click on the if you pick the material itself, the original include file, you can templatize this here too. So they will just invoke the editor tool. Okay, going back to the presentation. The second enhancement is regarding the radios connection. So not long ago, we introduced auto handling of include files in OptiStruct connection. So similarly, the capability has now been introduced for radio side, and whatever include file is referenced in a starter file, whether it's just a simple include or initial state STA file, they will be automatically copied to the run directory. So for this particular enhancements, I'd like to thank the radios team, as the lion's share of the enhancement effort belongs to them. I won't do any demo for this one. I think it's clear enough, So the third one is the model settings. What we've done here is we introduced a new attribute for our models. It's a new column option settings. It basically enables models to behave in specific ways, and it's currently limited to only 3 of them: motion view, hyperview, spreadsheet. If I show them on the fly in a demo model, where is that? Model settings, here we go. So for example, for motion view, in the settings options, we have use socket connection or solver, that type variant. So you might want to use the motion view connection, using a socket connection way, or you can use a non-socket connection way depending on the for your priority. Uh, Also, now instead of specifying the solver type or variant in the solver input arguments, we move it to the settings options. And similarly for the hyperview, previously, if you wanted to have images of your hotspots, you had to come to the solver input arguments and put minus image. Now we move that option to a settings area, capture image option. And also for spreadsheet, we have the save spreadsheet option, whether to save the updated spreadsheet session into run directory or not. So this is a new attribute for the connections area. Okay, so this is what we have for the connections and integration. Now the second category is methods and tools. We have 5 enhancements in total. The first one is in the sampling area. This is an exciting one. We introduced a new sampling method called Sobol sequence. So it's among our other DOE options right now with this release. Some of you might already be familiar with the Sobol, but basically it's a wide known low discrepancy quasi-random sampling scheme. It really shines in correlation performance and corner coverage. Like in certain areas, it might be really useful to use Sobol. And it's extensible and it supports DV constraints. The second one is related to predictive models and their efficiencies. When we introduced zero gradients, the application of it was really limited to optimization only, and namely on GRSM. It is now extended over to predictive models, which enhances their efficiency and accuracy both. Essentially, you're just lowering the dimensionality, right? Which is going to help the mathematical model. You don't have to do anything. You just, let the HyperStudy decides or finds the zero relationships or gradients, and the fit models will automatically consume them. Understanding design variable constraints. Design variable constraints have been useful to redefine the initial design space, depending on your engineering needs and specifications. However, in some situations, the number of acceptable design points might be small, or there might not be even a single acceptable one. So it is crucial to understand the contribution of each constraint so the explorers can identify the most restrictive ones, and they might want to reconsider the definition of them. So for that matter, we're introducing individual pass rate for each constraint, as you can see here on this column, which the individually evaluates each constraint towards some number of runs generated in the background. So what we do is basically we create 1,000 runs in the background using the MEL scheme, and individually look at each constraint's effect on the feasible or acceptable runs. In here, for example, the constraint one has 81, 80, around 82% pass rate, and the constraint tree is 95. So we can see that the first one is being the most restrictive one here. And also we introduced the combined pass rate. So this is a combined effect. So it starts with the first constraint and eventually boils down to 60 something percent here. The fourth enhancement is in the data extraction tools. So we've been pretty busy with the data source extraction tools recently. We recently introduced the regular expressions. Now in this release, we'll have the XML option too. This will allow explorers to extract data directly from XML files through a user-friendly interface. If I'll just quickly demo this one. Okay, let me just go to the run directory. So if you have an XML file which has like all the outputs and stuff you're interested in as KPI, you can pick the XML tool option here, and we have two ways of finding the value or the response. So either you can just select the path by just clicking on the value itself. It will just find where it is in terms of like an XPath, or you can just define the path yourself. If you pick it and if you have some repetitive items like you have the option to select them all and this will just turn into a vector, or you can just remain with the whatever you pick on the screen. So with the select all occurrences, it will just find all the value, under the same list. For example, item list here has, repetitive items, but with different volumes, but still you're capturing the value element here. It will just put all them into a vector. Or you can just, specify the path yourself. For example, in this one, I'm picking the first item in the item list. You can change that number to, for example, second item or third, and etc. Okay, go back to the presentation. The last enhancement in this category is the regarding the regular expressions to extract data from text files. So we introduced that feature or tool in the last release, the previous release, but the limitation was that it could extract a single response at a time. Now with the file assistant tool, the explorers can extract multiple responses at once. I'll demo this as well. Okay. Again, going to the run directory, if you have the an output text file, you drag and drop, the file assistant will have the HyperStudy text extraction option. And in here, we have three different ones, fixed with text. This is an ASCII extractor, the regular expressions, which we talked briefly, and then multiple regular expression option. This is the new one. So when you move to the next page, when you have different variables, and here we have three different like attributes or or a selection process. Typically it's on label by default. So whatever what it does is just picks the characters before the delimiter, and it defines it as a the variable name. Also you can do a custom. You can go with the custom option and define your own regular expression here to pick the name. But typically keeping it label is the way to go. Delimiter option, we have separator options like equal sign, comma, colon, white space, and etc. In this case, all these variables are separated with the equal sign with their respective values. Also, you can have your own custom option. And the value, we have different types of value options, real, integer, string, and etc. Again, you have the custom options if you want to go with the a detailed definition of your regular expressions. And when you click on finish, it will just give you all four different responses here with their respective data sources. Okay, final area where we have enhancements and improvements is the post-processing and visualization. We have only one item here, which is the user channels. From time to time, we were receiving requests to have additional responses independent of any solver process, such as metadata information. And also another request was to hide some of the built-in channels to make it tidy and easy to navigate around rather than scrolling through through a long list. So we introduced a study level global options user channels to cater to this request. I'll demo this. It's going to be much clearer on the demo model. Okay, so when you're in the study, when you click on these the study level, there will be another tab option, user channels. In here we have some metadata type responses, or the user, the explorers can come up with their own response type. Can be anything really. So it's up to your imagination, or up to your whatever you need for yours. The particular study. Here, for example, speaking of hiding some channels, we have link inputs and gradients. For example, in this study, I have a long list of gradients, and say 5 of them are active or all of them are active. When you go to post-processing area, and you'll see all these gradients in the channel selector area, which can be busy depending on how many you have. But in user channels, we can just turn them off. If you just go back to the post-processing area, they don't exist anymore. So it will just keep things tidy, Also, we have some, you might have some linked variables, and there might be also unnecessary or unneeded in the channel selector area. You can hide them here as well. And some of the useful metadata information options are here. For example, the origin approach. This can be useful, especially when you're dealing with bubble plots. If you go to the post-processing area again, get the bubble plots. Let me go to the second one. This will be a good example because this DOE1 data is being imported into the second DOE here. So we can see the source of the data, incoming data, in the respective approach. So when you have a pair and bubble plots, one of the channel or dimension can be the original approach. And if you look at it, so we just color code them in the graphical area, so you would know where the data is coming from. So the encoding one for is for the DOE one, and the second one is the respective DOE here. And like I said, you can define your own response type here. For example, this guy here, percent with the bounds. What it does is it just checks every DV for every design point, and it interrogates whether the current value for each design variable is within the proximity of the bounds with the given tolerance value here. So if I go back to the post-processing area, let me just activate it first. Okay. If you go to post-processing area, you'll see the bound check for every active variable here. For example, diameter. If you look at diameter at bounds, so the red color coded runs are actually falls within the tolerance value which we define in the user channels area. So the red ones are actually 10% in the proximity of their bounds, upper and lower both, and goes on for the other variables in the study. So this will be interesting in optimization, for example. That would just give you an idea which runs are actually really pushing toward the fringes of design space. So all these, user-defined responses can be registered through the preference file in the installation directory under begin user channels. So we have some examples also in the examples folder under etc user channels. You might want to go look at the input at bounds, which I showed right now, and have an idea how to construct the user-defined responses and register through the preference file. So that's about it. And if you have any questions, we'll be more than happy to answer. Thank you all for your attendance.